Hello, today we're going to talk about correlation. I'm going to just introduce some basic ideas about correlation to you today, and we'll get into the finer points as we get going in future lessons. So again, we are starting into inferential statistics. Inferential statistics are where we take two variables or more and we start to look at patterns between them to see if they might be related to each other or not. Maybe one variable affects the other, for example. And so correlation is a very simple way of doing that, a very basic way of starting to assess for that. However, it's also misused, which I'll cover in future lectures as well. So what it does essentially is it looks at the value of one of the variables for any given observation of it. So I don't know, let's say your age, for example. It looks at your age, and then it says, let's look at another variable that also is measured in you, maybe your height. And let's see if as your height increases or as you have a high value of height, do you have a low value of age or a high value of age, or can I not tell? That's essentially the basic idea of correlation. It assesses whether one variable, as it has a high or low value or a middle value, what does the other variable with which it is paired have? Does it have a high value, a middle value, or a low value? And that's essentially it. We're going to talk specifically about how to interpret one portion of correlation today, and then we'll get into the other things later. So we represent correlation with the letter R, the lowercase italicized letter R, the Roman letter R. That is called the correlation coefficient, and we'll just refer to it as the correlation. We'll refer to it as R. We can also call it the correlation coefficient. All of that is perfectly fine. Now, we need to know two things about R, and we're going to cover just one of those today. In order to appropriately interpret it, we need to know its direction, which is what we're going to cover in just a moment. And then we'll cover in the future interpreting its strength and how we talk about its strength. But first, let's just talk about its direction for today. So there can really be three directions for R. R can be positive, R can be negative, and R can be just sort of non-directional, I suppose. It can be too weak to say that it has a direction, but that's starting to get into the strength, which we'll talk about more next time. So the direction of R just means we need to know is R a positive or negative number? Now, when you calculate the actual R, which we'll do in the future, if R is a positive number, then R is a positive correlation as well. It associates with a positive correlation, again, depending on whether it is too weak or strong, but we'll get into that. Okay, so positive R essentially means that as the value of one of the variables is high, the value of the other variable is also high. And by that same token, it also means that if the value of one of the variables is low, then the value of the other variable is probably also generally low. Now, it doesn't have to be, but the general pattern would be that it is also low. In other words, you could also think about these two things. If a positive correlation means that the two variables tend to match each other in value, we'll say. They both have a high value, they both have a low value on average, or they both have a middle value on average. Okay. One way to think about this is also in direction. So you could also say that as one of the variables increases in value, the other one also tends to increase in value. And a lot of students also sort of discount the opposite, which would also be true, is that, well, it's not really the opposite, but it's the same thing. It's just using different language. That as one has low value, the other one also has low value. Or as one variable decreases in value, so too does the other. That is still a positive relationship because they change together, or they tend to share the same value, roughly high or low. Okay, so for example, you could say that high cholesterol is associated with a high risk of heart attack. Because both of them are high, a high cholesterol is also associated with a high risk of heart attack. That is a positive correlation, assuming that this is actually true, and of course it is. By the same token, however, low cholesterol would also be associated with generally lower heart attack risk. Okay, so this is a positive correlation, even though the low might indicate to somebody that's something negative, but of course it's not. Okay, so if that's a positive correlation, let's talk about a negative correlation. A negative correlation means that your R value is negative, right? It's literally a negative number. And it also means that if you have a high value in one of the variables, it's associated generally with a lower value in the other variable with which it is paired. And the opposite is also true, that a low value of one of the variables is associated with a high value of the other variable. It's the same thing, just said in a different order. So using that same metric that we used last time, as one of the variables values increases, the other one tends to decrease, and vice versa. It's the same thing, right? Just set in a different order. So that is a negative R value, or a negative correlation. For example, low physical activity tends to be associated with a higher body weight. And then same thing is a higher body weight also tends to be associated with a lower physical activity. So it doesn't matter the order in which it goes, this is a negative relationship. As one increases, the other tends to decrease, and vice versa. Okay, now let's also look at this visually. This may be helpful because when we graph a correlation, we use something called a scatter plot. So we haven't really talked about that yet, but I'll show you that now. This is an example of a scatter plot. There are, of course, lots of different kinds of scatter plots. Simply, you can have complex scatter plots, and I just happen to choose these. Now, this is the association that you would generally find in reality between height and weight, for example. So down here on the x-axis, I've got weight in pounds. Obviously, the metric should matter. And then height in inches, assuming that we're over here in the States. Okay. And every one of these dots now represents a single measurement of both of these. In other words, one unit of measurement from which we obtained a measure of both weight and height. Okay, so in other words, let's say that this dot represents somebody named Jill. Okay, now as you can see, Jill falls right along the 180 on the x-axis, meaning that we can tell Jill is 180 pounds. We know that she's 180 pounds because that's where she falls on the x-axis. This person over here weighs approximately, I don't know, 138 pounds or something like that, right? But Jill over here weighs 180 pounds. And then we also know her height. She is 63 inches tall because of that. So because of those two characteristics for Jill, she goes right there on our scatter plot. Now the rest of these dots represent somebody else, right? Some other people. And we don't need to name them all. But if this is our scatter plot, what we can see here also is there's a general trend kind of towards the lower left to the upper right. If you were to just sort of estimate what is the pattern, could you draw a line just sort of estimating that would be as close as possible to all of these dots? It would be somewhere kind of in here. Now, we will be able to actually draw a sophisticated one and a precise one later. I'll teach you that in the future, though. But for now, if you were to just estimate it, you'd say it slopes from the lower left to the upper right. That is the definition of a positive correlation also, because as you can see, as this value rises, as your weight in pounds rises, so too does the height in inches rise. People with a high weight in pounds tend to also have a high height in inches, and the opposite is true. People with low weight in pounds tend to have a low height in inches. So by definition, this is a positive correlation. So this is what it looks like in a scatter plot. Let's see what a negative correlation looks like in a scatter plot. So as you can see here, same thing, but I changed up the measures here, the x-axis and the y-axis. Fuel efficiency on the y-axis and speed on the x-axis. Now, a little point here, it actually doesn't matter which one is on the x-axis or the y-axis. I could flip these around and you would still see the same pattern, right? In fact, I'm jumping ahead here, but there is no independent variable or dependent variable in a correlation exactly. It's really just sort of theoretical. Sometimes people sort of assume one is the other or one or the other, but I'm jumping a little bit ahead. In any case, so this is a negative correlation because as you can see, as your speed increases, the value of the fuel efficiency tends to decrease as well, okay? So in other words, let's imagine that I took out a bunch of vehicles or a bunch of time trials, for example, and as I sped up and I averaged, let's say 63 miles per hour or something, then I tested my fuel efficiency, and maybe this is different vehicles. So every dot represents one vehicle, and I did these two measurements for each vehicle, perhaps. Could also be a trial run, doesn't matter. In any case, the point is, as one increases in value, speed increases in value, you tend to have a decrease in fuel efficiency, and vice versa. As I increase fuel efficiency, I tend to decrease my speed. Okay, so that is by definition a negative correlation. As the value of one increases, the level of the other decreases. And as you can see, it's a negative correlation because the slope goes from the upper left to the lower right. And that, again, is a definition of a negative correlation. Now, one thing I haven't noted here is that there is no correlation as well. It's certainly possible to come up with no correlation. What that essentially means is that you're not getting a clear pattern in the slope, or the slope just isn't strong enough for you to be able to sort of confidently say that as one increases, the other decreases, or they both tend to increase together. So if you just can't tell, if you really can't reliably tell, that's called a negative correlation. Now, that depends very much on the strength of the correlation, and so that's something that we'll get into in the next video, as I said right there. So quick summary, quick recap of what we've done here. Correlation is a way to explore what one variable does as the other variable behaves. So in other words, what is one variable doing as the other one increases or decreases in value? So what you can see here is a correlation sort of requires, at least this kind of correlation requires, both variables are continuous, or sort of like we've talked about before. There are some other special methods of correlation that just need binary or dichotomous variables. We're not going to cover that for this particular course, but they do exist if that's appropriate for the kind of test that you're running. And to interpret correlation, we need to know both the strength and the direction. All we talked about today was the direction, although I introduced the idea of strength ever so briefly. But we'll get into strength next time. As we talked about, a positive correlation is where the variables tend to do the same thing together. In other words, as one rises, the other one also rises, would be positive. Then a negative correlation is when they tend to do the opposite thing of each other. As one rises, the other falls, and vice versa. So that's it for today. We'll get into strength next time, and I'll see you then.